All right. In this video, let me tell you how to implement the binary tree in C++. Okay. So in the previous videos, you may have got an idea about trees. You know what are trees, how do they look like, and how to approach with trees. Okay. But that won't be enough. All right. So here we'll try to implement binary tree in a programming language in C++. In C or C++, I'll I'll show how to do that. Make sure that you can do the same in any programming language that you want. Okay, if you want to do that in Python, you can do. I'll tell you the idea in Python too. Okay, so you can use any programming language you want. You are not constrained to use C or C++, but in this course I will follow C or C++, but I'll be clearly explaining all the algorithms for the problems that I'm going to solve, so that you can implement it in Python also, Python or JavaScript, in any programming language that you wish to work for, right? All right. So, implementing binary tree in C++, I'm going to use some concepts for it. First one is a linked list. Okay. I hope you know about it. Linked list is a linear data structure. All right. So I'm going to use it in a non-linear way. Understand that tree is a non-linear data structure because it's not gonna have one after the other, or like an array or a linked list or a stack or a queue, whatever you call. It's not gonna have the elements one after the other. Rather, it's gonna be a complex structure. It's gonna be hierarchical. Okay. It's gonna be the hierarchical data structure, okay, that we follow. All right, you know about it. Okay, so I'm going to use linked list, or I could say link approach. Okay, linked list approach in order to implement trees. It's not going to be the same exact linked list what you have studied in your data structure concepts. It's not going to have one head and one data. It's going to have it's not going to have one next pointer and one data field. Okay, a linked list will be having two fields, right? Basically, if you have it, it will be having one data field, and it will be having one next pointer or next field, which will hold the address of the next node. Okay, which will hold the address of the next node. So in each linked list, there will be nodes. Okay, in each node you will get two fields. One is called data field, and another one is the next field, which will hold the address of the next node. Okay, that's how they are linked together. That's how they are linked together. Okay, but in this approach, please try to understand that I'll be having one data field here, and I'll be having two, pointer fields. Okay, they are called. Let me call them as pointer fields. One is called as left, and another one is called as right. Okay, so I'll be having two pointer fields basically. One is called as left pointer, and another one will be right pointer. Basically, one will be connected with the left node, and another one will be connected with the right node of the tree. Okay, I hope you got it. Let me take a simple binary tree example. Oh, okay, all right. Oh, if this is the binary tree, simple binary tree. Let me say this is 1, and this is 2, and this is 3, right? So as you all know that here this is called as head or root. Okay, head or root. Okay, and 2 is connected to 1 as a left node, and 3 is connected to 1 as a right node, right? As a right node. All right. Now how will I implement this as a linked list approach? Okay, as a linked list. All right. So let me have one node here. Okay, whose data will be 1 basically. All right, and let me have another node whose data will be 2 basically, and this node will be having a data of 3. All right. Here if you see here if you see the left field of this particular head or root node will be pointing to the left node. Okay, will be pointing to the address of the left node. For instance, let's say the address of this particular node, because this node will be stored in our data, right? Of course we'll be allocating memory for it using our malloc function. Okay, I hope you know about the basic concepts of linked list, then only you will be able to understand it. Okay, so this course is for intermediate stuff programmers, because you should be able to understand this. If you are a beginner in DSA, okay, if you understood the concepts of linked list, dynamic programming, I mean dynamic memory allocation, then you will be able to understand it easily. Okay, let me say this is stored in the memory address 1001. Okay, let me assume like that. This address will be usually a 32-bit or a long number, but let me assume it as 1001 for my easier computation. Then this will be holding a value of 1001. That is not actually a value, that is nothing but the address of the left node. Okay, address of the left node, so that it can easily locate the next the left node. Okay, and here let me say the address of this node is 2001. Already address of this node is 2001. Then it will be storing a value or address of 2001 so that it can point to the right node. Okay, so that it can point to the right node. Now you may ask a question, then what are the values that are stored here, that are getting stored here? Okay, what are the values here? Okay, here at these points, what are the values? Okay, since these since these nodes 2 3 are leaves, okay, they are called as leaves, which means that they are they form the end of the binary tree. Okay, they form the end of tree. Okay, you know, after the leaves, if you go beyond the leaves, we do not have any connection. Okay, we do not have any nodes. All right, they form the end of the tree. That's why they are called as leaf nodes. Okay, so when you talk about leaf nodes, they form the end of the tree, so they will simply have a value null. Okay, they cannot, they cannot point to anything. They can have only null. All right. Okay, so please have a note on this. All the leaf nodes left and right pointer will be having a value of null. All right, this will be very useful to write your base cases while implementing this. Okay, so please try to understand that the left and right nodes of the leaf node, left and right fields of the leaf node, okay, of the leaf nodes, they will be having a value of null. Only the leaf nodes. Okay, the left and right fields of leaf nodes. Okay, all right, let me try to produce one more example. Let me say 1, let me say 2, 3, 4, 5, 6, 7. Okay, this tree looks somewhat bigger compared to the previous one. In that case, my my representation would be like this. Okay, now 2 and 3 are not leaf nodes. Please try to understand, 2 and 3 are not leaf nodes. They are internal nodes. Okay, any node other than the leaf nodes are called as internal nodes. They will be definitely having the left and right pointers. All right, any one of these or both of these. Okay, sometimes you can you can draw like this also. This is also possible. Okay, in that case the right node will be null. Okay, let me draw like that. Okay, let me assume that this is my tree. Okay, in that case the right node will be null, the right node alone will be null, the right field will be null, the right field will be null because it's pointing to nothing, so which is symbolically represented as null, which means it is pointing to nothing. Then here you'll be having 4 whose left and right both will be null. Okay, here you'll be having 6 whose left and right both will be null. Okay, so the left will be connected to here, the left of the node 3 will be connected to leaf node 6, and right will be null again. Okay, right will be null again, right? All right, this is possible, this is possible actually.